Welcome to this video on Kubernetes core concepts. Today, we're exploring one of the most fundamental building blocks of Kubernetes, the pod. Understanding pods is essential because they form the foundation of everything you'll deploy in a Kubernetes cluster. Let's dive in and discover what makes pods so important in the world of container orchestration. So, what exactly is a pod? A pod is the smallest deployable unit in Kubernetes that represents a single instance of a running process in your cluster. Think of it as the atomic unit of deployment. You cannot deploy anything smaller than a pod in Kubernetes. Every application, every service, every workload you run will be packaged inside a pod. This makes pods the most fundamental concept you need to understand when working with Kubernetes. Now let's look at what's actually inside a pod. A pod contains three main components. First, containers. A pod can run one or more containers together as a cohesive unit. Second, storage. Pods can have shared storage volumes that all containers within the pod can access. And third, networking. Each pod gets its own unique IP address on the cluster network. These three components work together to create an isolated execution environment for your applications. Pods can be configured in two main patterns. The single container pattern is the most common approach, where one pod contains just one container. This is how most applications are deployed in Kubernetes. The multi-container pattern is used for tightly coupled workloads, where multiple containers need to work together and share resources. For example, you might have a main application container alongside a logging or monitoring container. Both containers in the same pod can communicate efficiently and share the same network and storage. Let's talk about how networking works in pods. Each pod gets its own unique IP address, making it individually addressable on the network. All containers within the same pod share a local host connection, meaning they can communicate with each other as if they were running on the same machine. Containers within a pod also share the same network namespace, which includes ports and network interfaces. When pods need to communicate with each other, they use their unique IP addresses for direct pod-to-pod communication across the cluster. Here's what a basic pod definition looks like in YAML format. The API version is v1 and the kind is pod, which tells Kubernetes what type of object we're creating. In the metadata section, we define the pod's name, which in this example is my dash pod. The spec section is where we define the containers. Here we have a single container named Nginx, using the Nginx latest image from the container registry. We're also exposing container port 80, which is the default HTTP port for Nginx. This simple YAML file is all you need to create and run a pod in Kubernetes. Pods go through different phases during their lifetime. The lifecycle starts with the pending phase, where the pod has been accepted by Kubernetes, but the containers are not yet ready to run. Next is the running phase, where at least one container is actively running and executing your application. After the work is complete, a pod can enter the succeeded phase, which means all containers have terminated successfully. Finally, there's the failed phase, which occurs when a container terminates with an error. Understanding these phases helps you monitor and troubleshoot your applications effectively. Let's recap the key points. Pods are the smallest deployable units in Kubernetes, serving as the foundation for all your applications. They can contain one or more containers that share resources like network and storage. Each pod has a unique IP address and a shared network namespace that enables efficient container communication. Finally, pods are ephemeral by design, meaning they're temporary and designed to be replaced rather than repaired. This ephemeral nature is a core principle of Kubernetes that enables scalability and resilience. Thank you for watching, and see you in the next video.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.